Alright, factoring by grouping is reserved for when you have 4 terms. So, for example, does it always work? No, none of these techniques always work. Just you try them and sometimes they work. So factoring by grouping, you take the first 2 terms and then you do GCF on each of them. So what's the greatest common factor in these two? It's a y. You got y plus 3 left over. What's the greatest common factor here? 4. And you got y plus 3 left over. And you see how this one and this one matches? Essentially what you're doing is you're factoring that out. And you got y plus 4 left over. Where did I get the y plus 4 from here? And that's the y plus 4. This is the answer. Alright, let's see. We got 4x squared minus 3x plus 20x minus 15.
But no coconuts.
You got 4 terms. So you're going to group these two together and do greatest common factor on each. So just focus on these two. What can we pull? We can pull an x. And we have 4x minus 3 left over. And over here we can pull a 5. And we'll have 4x minus 3 left over. And you see how these match? You pull that one out, and what do you have left over? An x plus 5. You know it's a plus sign because it's positive right here. What if you had no numbers? What if it was all variables? Pretty scary, right? But it's exactly the same thing. So you go ahead and you group the first 2. And you group the second 2. And you have, can we pull from here? In a, we'll have x squared plus y left over. And what can we pull from here? Now you might be thinking, well, let's just pull out a b. But then you have minus x squared minus y left over. And you see how both of these are positive and both of these are negatives? How do we get rid of the negative sign? You pull out a negative 1. Right? Because that's negative bx squared, negative by. Alright, so these are the same now. Now you have a minus b. And that would be the answer. Four terms, factoring by grouping. Pull out an x. Pull out a 4. See how those match? Alright, I'm done with factoring by grouping. Alright, for trinomials that are of the form ax squared plus bx plus c, you can really think of them as being case 1 and case 2. In case 1, the leading coefficient equals 1. And in case 2, the leading coefficient doesn't equal 1. For case 1, you just need 2 numbers that multiply to the constant and add up to the middle term. And for case 2, you got to multiply a times c. And you need 2 numbers that give you that same value and add up to the middle term. And then we got to expand the middle and then factor by grouping. But this is best taught by showing you how to do it. So let me give you an example of this one. Alright, you see how a is a 1? That means it's case 1. So all we need is 2 numbers that multiply to the constant. So 2 numbers that multiply to negative 10. But when we add them, we get the middle term, which is negative 3. That would be negative 5 times positive 2. Right, that's negative 10. But if we add them, we get a negative 3. And now we're done, because your answer is going to be x minus 5 times x plus 2. Yep, those are the two factors. That's why factoring can be really easy, because if you know the techniques, then you can come up with the two factors very quickly. Alright, this is also a trinomial of ax squared plus bx plus c. The leading coefficient is a 1, so it's a case 1. I like to call it a case 1. So I need two numbers that multiply to minus 14 and add up to 5. And that would be 7 times negative 2, because 7 plus a negative 2 is a 5. And because it's case 1, I'm done. So it's x plus 7, x minus 2. This is also case 1 because the leading coefficient is 1. So I need two numbers that multiply to 32 and add up to 18. 8 times 4... 16 times 2. And 16 plus 2 is 18. And because it's case 1, I'm done. Y plus 16, y plus 2. Alright, let me show you some case 2s. Scroll up. We see 6x squared minus 5x minus 25. I need my calculator for this, so here we go. Alright, this is definitely an ax plus bx plus c trinomial, but the leading coefficient is not a 1, so we're case 2. So we need two numbers that multiply to 6 times negative 25. So negative 150. Right, 6 quarters is $1.50. But they have to add up to negative 5. Oh my gosh, I got it. Negative 15 times 10. And because when we add them, we get a negative 5. But now we need to expand the middle term. So instead of writing negative 5x, we're going to write negative 15x plus 10x. And then we're going to factor by grouping. Right, so the 6x squared stays the same. Instead of minus 5x, I'm going to write this. And then the minus 25 stays. And now I'm going to factor by grouping. What can I pull here? I can pull a 3 and an x. And what can I pull here? I can pull a 5. And voila. You see how they match? Can we still see on the... Yeah. Alright, but I'm just gonna... wonder if I write here, you'll be seeing. I hope you can see the answer. 2x minus 5, 3x plus 5. I think you can still see it. And that would be factoring by grouping. Let's try it again. 2t squared minus 5t squared. What? I'm very wrong. 2t plus 5t squared minus 3. The first thing is it's not in this form because the degree 2 term is in the middle. So we need to rewrite this. And you can see that a is 5, so it's a case 2. We need two numbers that multiply to negative 15. Add up to the middle term. So negative 5 times, no, positive 5 times negative 3, because 5 plus a negative 3 is a 2. So instead of writing 2t, I'm going to write 5t minus 3t. So 5t squared plus 5t minus 3t minus the this one, minus 3. And then we're going to do factoring by grouping. I can pull a 5t and I can pull a minus 3. And my answer would be t plus 1, 5t minus 3. Right, so this was a case 2, factor by grouping.